Now, if our pendulum is swinging back and forth and the water level is rising, then our drag force is still going to be a function of V. So let's just put a V over here. But it's equal to something times V. And this something is going to change as the water rises, because as the water rises, the pendulum has to push more and more water out of the way. So what are we going to put in here? Well, we had C here, and of course we had a negative. I'm going to use C again, but this time I'm going to say, well, we don't know exactly how the water's rising. We don't know the exact shape of the pendulum, but if we know the shape of the pendulum and how fast the water's rising, then the number that we're going to multiply by the velocity to get the drag force is going to somehow be a function of time, so that our drag force is the form C of t times V. Now this leads to an equation very similar to the one we had before, but instead of x double prime equals negative k over m times x minus just a plain old constant times V, we're going to have to let C be a function of t so that C no longer stands for constant, and we have a function of this nature, and the way that we represent that function would be x double prime is some function of, I'm going to have t first, bad looking t, but we'll have to live with it, t x x prime. Of course, the x prime is your V, and I suppose that I could change that to an x prime just to be explicit about how that works. So our f of txx prime is negative k over m x minus c of t times x prime. Function now of three quantities instead of the two that we had before. This equation will generally be very difficult to solve. The nature of the C function is going to depend on the shape of the pendulum, and it's going to also depend on how quickly the water is rising.